So continuing with the notes for 2.5, I'm going to just lay out the steps for you for doing implicit differentiation. Remember, when you use it, you're going to use it when both x and y are on the same side of the equation. Side of the equals. So there's basically 4 main steps, and your book lists these out also. The first one is to take the derivative with respect to x of both sides. And we've got different notation for taking that derivative, and I've been trying to give them all equal time. I haven't given this capital D one much time, but the reason is it's not used a whole lot. But for implicit differentiation, this one actually I think will keep you from making some common mistakes that are made when using this, and for those who use this exclusively. Now some of you, after a couple days of this notation, I think will be ready to go right to here, and we'll talk about that when it happens. But for now, we're going to take the derivative with respect to x, again that's just the notation, of both sides of the equation. Step number 2, we are going to remember that all rules for differentiation apply. What that means is that when you take the derivative of a constant, you're still going to get 0. It means that if you have a product, you're still going to have to use the product rule. The first times the derivative of the second, plus the second times the derivative of the first. If you need to, you might have to apply the chain rule. So any rule that we already have can get applied at step 2. Step 3, and from here to here, I'm going to have you write a little arrow. Once we do about 3 or 4 of these, you'll get the value of this. But from step 2 to step 3 is kind of where we're going to switch notations. But we are going to collect all terms involving y prime, or the derivative, on one side. And I would tell you to do it on the left-hand side, just to have a system. On the left side of the equation. All right? And step 4, you're going to factor out y prime and solve. And until we've really done a few of those, that's a pretty confusing list of steps, but it's not going to be bad at all. We're going to start with what I would call an easy one. The reason it's easy is it doesn't have any embedded quotient rule or chain rule. It's pretty straightforward. So our first step is we're going to take the derivative, just like step 1 says, of the left side, and we're going to set it equal to the derivative of the right side. That's step 1. All right? And then step 2, where I wrote all differentiation rules apply, this is what I mean by that. We know that the derivative of a constant is 0. We also know that we can break up sums and differences. We also know that constants come out front. So what I'm going to do over here on the left-hand side is break it up into the derivative with respect of x of y cubed plus the derivative with respect to x of y squared, and where y is considered some function of x, minus 5, and I can pull that constant out front. And then lastly, the derivative with respect to x of x squared. And all rules apply here, and this is where from step 2 to step 3, where I wrote on your thing, go to y prime. I think you're going to like that better. It's just using this capital D does eliminate a very common mistake that I'll bring up later in class. But the general rule is we're considering y as a function of x. It's kind of like when we used to talk about u, and we used to say, well, if you're going to take the derivative of u and use a function of x, we'd say, well, it's 5u to the 4th times the derivative of u. We use our chain rule, and that's exactly what you need to do in all these cases, and that's why I like this capital D notation, because this is easy to spot. When the variables don't match, you're going to consider it the chain rule. So you're going to say, well, the derivative of y cubed is 3y squared times the derivative of y. And notice I changed notations here, and I think that'll be helpful for you. Plus, these don't match either, so I considered a chain rule. It'd be twice y is the derivative of y squared times y prime. Again, it's the chain rule is what you're doing. And on the next one, I'd have 5, the derivative of y with respect to x, right, as y prime. And my last one, when the variables match, I'm just asking you to find the derivative of x squared with respect to x, which is twice x. We've been doing that very consistently. So it's that step 2 to 3 where you might have some issues for a while, but we'll clean those up. Then this next step said to collect all terms involving y prime, because that's what we're ultimately trying to find is the derivative on one side. And I'd suggest the left-hand side. So those first ones I'm just going to rewrite. And you can see why I switched notation, because y prime is just so much cleaner than using this consistently or this consistently. All right, and the last step said to factor out your y prime. And solve. So if I'm going to solve this for y prime, all I need to do now is divide both sides by this. So I'd have y prime is equal to 2x over 3y squared plus 2y minus 5. And this is my equation that'll give me the derivative or the slope of the tangent line at any point on the curve. So what I would like to do next here, I don't think I'm going to answer these questions at the bottom quite yet. I'm going to save those for tomorrow. I will cover that. I want to do one more example of this, and then I want to do an AP problem that involves this, that has some trig in it. So the next one up, this one's a little bit more complicated. I'm still to find the derivative. Remember, that's y prime. I'm going to follow my rules. First one is take the derivative of both sides. So I'm going to take the derivative of both sides. All my rules apply. And so note what I'm saying when I say all rules apply is on the right-hand side I have the derivative of a constant, which is 0. On the left-hand side, I'm going to break up my sum. The derivative of a sum is the sum of the derivatives. I'm also on this next term going to pull the constant out front. Okay. Next up, right here, I'm going to call that 3x squared because my variables match. It's not a chain rule. It's just the derivative of x cubed is 3x squared. Notice right here, I've got a product. So I've got to use my product rule right here. So I'm going to put in parentheses. When I do the product rule on x times y, I do the first times the derivative of the second. And again, I'm switching notations in this second to third step, and I'm hoping we can do that pretty safely and smoothly. But I do the first times the derivative of the second plus the second term, which is y, times the derivative of the first. And the derivative with respect to x of x is 1. We've been doing that very consistently, so I would really have a little 1 here I'm going to insert. So I have a product rule embedded in there, plus these variables do not match, so I consider it the chain rule, which would be 3y squared times the derivative of y. My goal is to collect all terms involving y prime on one side, but in order to do that, I'm going to have to distribute. So notice all the heavy algebra. This is really just a lot of algebra is what it is. So right now I'm just distributing. Now I'm going to collect all terms involving y prime on one side of the equation. So I'm going to keep that on the left. I'm going to keep this one on the left. And I'm going to move the other two over. So I would subtract the 3x squared over here. And I would also subtract my 6y. And then, oh, I'm sorry, I've got a cough. So on the left-hand side, I'm going to combine two steps here. I'm going to factor that y prime out right now, so I don't have to rewrite it all again. So I've collected everything involving y prime on the left, and I factored a y prime out. At this point, to solve, I just would divide. So I'd have negative 3x squared minus 6y all over 6x plus 3y squared. And for now, that's all I'm going to do. This one on the bottom I want to do because it involves the trig, and we haven't had one of those. My fraction bars got lofted up here. So let's go put them where they need to go. Put one right here, right here, right here, right here, right here. And this is a multiple choice question off last year's AP exam, and I hope I have enough time to finish it. If not, I'll finish in class tomorrow. So let's take our original equation. It's sine of xy is equal to x, and I'm to find dy dx, which is really y prime and other notation. Now keep in mind, you would know this is implicit because I have both x and y here on the same side of the equation. So I'm going to start that process. My derivative with respect to x of sine xy is equal to my derivative with respect to x of x itself. Well, on the right-hand side, I've got a nice match. I just take the derivative of it as I normally would. The derivative of x is simply 1. Now, what I've got going over here on the left side, I've got the derivative with respect to x of sine xy. I've got a chain rule going on here, and I've also got a little product going on in here. So I've got lots going on the left, even though it looks kind of innocent. So I'm going to use my chain rule first, and my outermost function is sine. The derivative of sine is cosine. So I'd have cosine xy, and then I'd have times the derivative of that inside piece. And I'm going to keep my dx notation going here for a little bit. So what I have now is the derivative of a product. So I have to use my product rule. So I've got cosine xy, and then I've got product rule. So I'm going to go put my product rule in here. Remember what that is. It's the first, which is x, times the derivative of the second, plus the second, which is y, times the derivative of the first. And again, with respect to x, that's just a 1. I'm going to go put that in there. Bam. My goal is to isolate that y prime. In order for me to be able to do that, I've got to get it out of these parentheses, so I'm going to distribute. So what I end up with is xy prime times the cosine of xy plus cosine xy is equal to 1. And my goal is to solve this for y prime. So I've got to keep it on the side by itself. I'm going to keep it over here on the left-hand side. And on the right-hand side, I'm going to subtract off that cosine xy. It's a very methodical process, and this is one section where if you're copying a lot of stuff off of that Calc chat, it's really going to get you because you just need to kind of keep practicing the process over and over again. So I'm still at this point here where I'm trying to isolate y prime, which means I simply need to divide both sides by x cosine xy. And so I would say that my answer is D. And this is considered a very difficult AP problem. I would suggest what you do right now is you practice this one and the one above it and just write them out a couple times so you get used to the flow of it and the notation and the process. And once you have that down, they're all done kind of the same way. So I'm going to flip to the next page here and show you the answer from the AP test. And we did indeed get it right. It was D, and we should get it right. But notice this, only slightly over a third of the students answered this one correctly. It was very heavily missed. And I think what happens is they get lost in the notation and they changing from this to this. And I do think that that capital D notation might help you out here. So what we're going to do tomorrow is we're going to go work through these. We'll do some of the harder ones together just to get you in the flow of it. Other than that, the only thing you need to do is make sure you take that online quiz if you have not done so. You guys have a great night.